can still hear me, right?
Yes, ma'am.
Okay, thanks. What IEEE is doing in standardization with respect to other SDOs, especially in this area of emerging tech, such as functional safety. So, we have some mainstream or governing SDOs in this area, such as ISO, such as SAE and IEC, that have been traditionally driving standardization and are still driving standardization in this space with several basic standards such as the ISO 26262 for automotive. There's the IEC 61508, which is the mother of all safety related standards, and then there's the other standards that are now also being reformed, such as the ISO 21448 for SODIF, etc. So bottom line, a lot of the mainstream standards that are providing guidance and requirements for safety engineering work across the industry are being driven out of these SDOs like ISO, SAE, and IEC. And so the question was, what is the role that IEEE can play, and how can IEEE help in this space? So the role that IEEE has in safety and also overall dependability, because now we really have within the Computer Society an FSSC, which is the Functional Safety Steering Committee that oversees all standardization activities in the dependability space. So also including the other dependable technologies like reliability, real time, and cybersecurity. And so the role that IEEE plays in this space is that of supporting the current development and providing implementation guidance, providing interoperability guidance, addressing overarching aspects, with respect to other standards. So still maintaining complete alignment with, those mainstream or governing standards, but providing supplemental guidance, for implementing methodologies, tools, and data models and databases to execute the activities that are defined in those life cycles, in those mainstream standards. So we also cover standardization gaps. So there's new standards in various topics that are being now being formed as part of the study groups and standardization harvesting, so to speak, that is happening in these committees. So that was kind of the overall role of IEEE with respect to these other SDOs. Now, not to say that IEEE is not leading in other areas. Of course, in a lot of other technologies, IEEE still maintains that leadership, that governing role. But that slide was just intended to show our role in, some of these newer technologies like functional safety. In terms of B2851, as I mentioned, we do have companies that span across various different groups or companies across the value chain. We have the IP and IC providers such as ARMS, Synopsys, and others, and then we have the SoC or chip companies that kind of dominate the group. These are companies like Intel, AMD, NVIDIA, Qualcomm. We have a lot of EDA vendors there as well, including Cadence, Siemens EDA, and others, IROC-Tech. We are a little light in terms of the tier ones and OEM representation. Currently, we do have some participation, but heavier on the lower level of development in the stack. Over 70 individuals. So the reason I'm sharing this is to tell you that IEEE B2851 is one example of an entity-based working group. So when a standardization working group can be entity-based or individual-based. As a member, you can join, working group as an individual if you're an IEEE member, but you can also join representing your entity if it's an entity-based working group. And that entity doesn't have to be a company; it can be a university, right? So a university can represent, a student can represent the working group, as a representative of that university. So when we say entity, it could mean any body, including companies or universities that can contribute to standards development. And so any one of you could potentially join an existing working group or join a standards committee to participate in activities related to study groups and brainstorming, problem statements, etc. In the case of B2851 specifically, and this standard was kicked off in early 2020. So when we wrote up the problem statement or the project authorization request, that problem was related to interoperability or data exchange across various domains. That's what we are focusing on here, is how to provide a common framework or a common set of tools and methods that can facilitate the data exchange across application domains. Here you see automotive, industrial robotics, and avionics as examples, but we're looking at topics that are executed during the safety engineering life cycle that need to be executed in a domain agnostic way, such that you can easily exchange the data across the domain. So say I execute all of my safety engineering work for automotive, I should be able to reuse that for industrial or for medical or for avionics or any other safety critical application like railways or autonomous ships, etc. Today that's not the case, because each domain has its own governing standard that mandates the requirements that need to be complied to. So this is an example of a problem statement that we developed for P2851 to kick off the work. We also looked at interoperability across levels within a given domain, and then we also considered interoperability between the technologies. So looking at the technologies from a functional safety lens and understanding the trade-offs that you would need to make if you consider requirements from cybersecurity or reliability or real-time, and how do you comprehend those as you execute your activities. So here's the role. So you have your mainstream SDOs, right, which have the governing guidance in terms of the requirements and the safety engineering activities, and then you have P2851 that kind of spans across and acts as the glue that connects these different standards. And that's one example of the role that IEEE is playing in this space, as a supporting and overarching standard, providing implementation guidance for executing the different activities. And then the other thing that we're doing in P2851 is introducing this notion of dependability lifecycle. It's also published in a white paper that is now on IEEE Explore. It was published June of 21 by the working group, and that's where the dependability lifecycle was introduced based on the V model that is documented in ISO 26262. You see that on the right here, where you have all of the design activities here on the left side of the V and the verification on the right, and you have the different levels spanning across from IP, SOC, system, and item, and all of the safety engineering work that's executed for design and verification. And then here's the common format or common data format for data exchange that we are working on developing as part of P2851. On the left, you see an example of how the different activities across the technologies are staggered, such that you can achieve that common or holistic set of requirements that cover all of the technologies, and then you can iterate and make those trade-offs till you come up with that unified view. And that needs to be executed, step by step for inter as well as intra-level activities through the life cycle. Last year in the IEEE Computer magazine, we also published an article explaining more about the dependability lifecycle disk, as you see here, which shows also that iteration, so considering functional safety and then iterating across, considering all of these technologies, the cybersecurity, function, performance, reliability, and behavioral safety. And then on the left, you see here in the disks the different activities that are executed, including design, verification, integration, verification, validation, etc. So at each step, there are work products or artifacts that are generated, which contain the results, those analysis and verification activities. And that's where the interoperability comes in, because when you generate those work products that constitute your safety case, you need to make sure that they are not just considering one of the technologies, but looking at the complete view. And then we split up into subgroups. The subgroups collected all of the different needs and requirements from across the domains, looking at FUSA, AI, looking at cybersecurity, looking at storative needs, etc. And we came up with a list of 108 different needs in terms of description languages, methodologies, and databases. And you can see some examples here as topics. I've just to give you a flavor of the kind of needs that we collected. And then finally, I can jump into the roadmap. So this is where we are at today. By middle of this year, we plan to release our base standard. This is the domain agnostic dependability lifecycle for P2851. And then by end of the year, we plan to kick off the next revision, which will be domain-specific life cycles for automotive, industrial, medical, and avionics. And then we also will kick off the derivative or DOT standards, which will also include the work that is being done today by the Accelera Functional Safety Working Group. So we have strong partnership with Accelera, and we will be releasing their work on FMEDA and data models that they are developing as part of our DOT standards as well. So that was my last slide. I just wanted to share with you kind of flavor of some of the work that's going on in standardization for functional safety, for autonomous driving. And if you have any questions, please feel free to reach out to me at any point. And I hope to see more participation from academia and other entities in standardization. And so anything I can do to help encourage that, I'll be happy to do that. Thank you again for having me, for listening, and for attending the talk. I really appreciate it. Thanks so much.
Thank you so much, ma'am. I believe we have all gained valuable insight from the field of autonomous driving and importance of standardization in ensuring the safety and reliability of autonomous vehicle. So I say great talk of you, and I hope you have share your knowledge, experience with that. So thank you, ma'am, for with us. So if you have any question about this, you can send it in text box also.
Thank you so much. I appreciate it.
So then today's session, I am honored to have Professor Kathleen Kramer ma'am with us. She is distinguished lecturer in IEEE Aerospace and Electronic Systems Society, and she is also professor of electrical engineering at the University of San Diego. I am sure that her insight will be valuable for all of us, especially those of us who work in field of engineering and technology. So without further ado, I would like to invite ma'am to deliver her speech. Thank you, ma'am.
Thank you so much, and I want to thank you for and congratulate you for putting together a program. I'm thrilled to be on the roster with the speakers that you've put together. So my presentation is on navigation and GPS vulnerabilities, and I will run you through the entire history of the world from a navigation point of view. And we start with what you could call visual navigation. And even in the Odyssey, they refer the Greek work. They refer to whether it's visual cues, the mountains, the paths, and the coastlines, or solar navigation using the sun, or celestial navigation, the stars are well known. And an exciting example that I learned a lot more about when I was giving one of my distinguished lectures on the topic. I happened to be in Hawaii, and so I thought I should be prepared to have a discussion. And so I found out that basically 3000 to 1000 BCE, the Polynesian-based navigation, which is believed to have its roots in Taiwan, combined celestial navigation thousands of years earlier with position, horizon, landmarks, and then combining that with wildlife knowledge, weather relationships, ocean currents, and the technologies of shipbuilding. They developed guilds of navigators, traded them, swapped them. It was effectively human sensor data fusion thousands of years before we conceived the idea. We also have, as we transition from the visible to the invisible, almost simultaneously, the Vikings and the Chinese developed magnetic-based means that were used to tell direction. And so this is major because it's things that you cannot see, which is what much of what IEEE does, is things that you cannot see. The technology was born very early. This is a picture of a finding of a shipwreck from 1901, but it's actually 100 years BC that this mechanism was put together, and it's a mechanism for celestial navigation that can predict many years into the future. Here's a more modern take on it around 11th century, 12th century, 13th century, where you're starting to get compasses, and then the combination of direction and time, something that's colloquially called dead reckoning, which is where you don't really know where you're going, but you aim and you keep going and you hope that you get there. The combination of direction and time together can get you distance, and there's a device called the pitot tube that mechanicals are more interested in than electricals typically. And so you're measuring essentially velocity based on pressure, and then speed measurements can translate into position. The prime meridian, which gives us this basis of GMT, Greenwich Mean Time, which was definitely for our speakers today a concern to make sure, especially for me from San Diego, where I am GMT -7, and you might be GMT +6. And so this is how we measure it. It was first established. Yes.
I had.
And we were first established in 1851, and by 35 years later, prior to widespread communication in 1851, they had established this on 2/3 of the ships in the world were using GMT. And that shows the basis of timeliness for navigation, and by establishing a standard of time, you establish a standard of everything else. Oh, and there was a lot of, everybody likes to be the center of all things. And so GMT, Greenwich Mean Time, that's why it's London. And so it was intended to be 0, 0, 0. So we're going to start all our directions at 0, 0, 0. But there was, politicking and jealousies and moving things around. So things are not always as perfect as they are intended to be. Yet another kind of navigation moving from velocity is to consider acceleration. So moving up one more level. And so we have what's called an inertial navigation system, or an INS. And with an inertial navigation system, we combine sensors for motion and rotation. And so that's acceleration and accelerometers and gyroscopes. And an INS is a self-contained, really an integrated relative to a start point, and it computes its own navigation information. We have within it an inertial measurement unit, and this is an electronic device. And then at that point, we're over on the IEEE side of the house. And so we have angular and linear accelerometers, and these are used in ships, subs, aircraft, missiles, spacecraft, and now UAS or drones. And we work continuously. There's a great deal of effort to get systems that are less and less mechanical and more integrated. And so they're developed to provide guidance and between fixes that can be provided by the systems that are more obvious to us, including GPS, but basically celestial and radio navigation-based systems. As we move forward, navigating based on waves, and it just keeps coming back to the IEEE fields of interest. And so with radio, from the earliest 20th century and almost the discovery of radio, we start using it for beacons. And so getting bearings from known towers with known frequencies, and then you can determine your location by knowing your bearing or direction relative to 2 or more locations. And so certainly by World War II, we were using high frequency radio-based direction finding. And then ADF, automatic direction finding, is used in currently today and for not quite a century, almost all modern aircraft based on AM radio. Moving from radio to radar, we have radar itself, the word, is radio detecting and ranging. And with radar, we're sending out a short, high-intensity burst, and we're waiting for it to bounce back at us, and we're using the measurements based upon that. And so my society would never change its name to the Radar Society, but there's the big gorilla in my society that's not really my side of the house, is radar. And so, but they don't want to be the Radar Society because AESS, Aerospace and Electronic Systems Society, is first alphabetically. And so they much prefer not to have radar in the title. So short, high intensity, high frequency bursts. And so this echo, and you can end up with a Doppler frequency shift and measure relative speed. Modern navigation, in contrast, is often remote from, if you think back to the more, as a navigation has evolved, it's about individuals or groups or ships navigating for themselves. With modern navigation, we have navigation that relies on other people. And so even prior to GPS, we had ground-based air traffic control for all the aircraft. Pilots need information from someone on the ground, starting in 1921 and in use today. So currently, there's anything from 6,000 to 13,000 aircraft, not including drones, that are flying simultaneously at any one time. We still have a high altitude 70s era computer called the host that's involved. We have communication link and identification required just to avoid catastrophic crashes. And the Europeans have similar systems. We're keep saying we're about to get next gen. It's been, next gen is a very poor name for a system since it implies next generation. It's not going very, very quickly. So finally we get to space-based navigation. So there's remote where you're at the air traffic control that you're relying. And then when we move to space for our sources of information, the US engineers decades ago discovered that Sputnik, a Russian vehicle, could be located based upon its radio signal and an interpretation of the Doppler shift. So the GPS was an extension of the US Navy's satellite navigation. And it was a defense system originally started in 1973. It's based on precise clocks on satellites that are transmitted by radio signal, and using those precise clocks, again, time-based navigation, and why Greenwich Mean Time was so immediately popular, even in almost a pre-EE technology era. So the precise clocks transmitted by radio signals determine location. So the first block was launched first block satellites were launched in 1978. And remember, it was then intended as a military defense system. And when a civilian aircraft was shot down in 1983, killing all on board, this may cause the transition of GPS into a commercial navigation, to meet commercial navigation needs, to avoid such tragedies. And Block 2 was launched by 1989. And the idea, or the constellation, as we call GPS, is for 24 satellites in operation. The most recent launch was 2 months ago, in January, and we're in the sort of the new era of Block 3, and there's 5 in operation and 6 up there. We're looking for GPS to help us with position, navigation, and timing together. And this is known by the acronym PNT. And this is a lovely picture of that I borrowed with attribution from the Smithsonian, as you can see there. So as of today, and I checked last night, there's 31 operational satellites intended for a 24 constellation. That's the space-based part of the system. On Earth, hundreds of millions, if not billions, of GPS units are relying upon these signals. GPS isn't the only thing in the game. GLONASS, the Russian system, and now in only recent years up to 24 satellites. It was made a priority of Putin. Galileo, the European system, is now finally up to 24 satellites. Beidou, the Chinese system, is up to 44 satellites, and it has 2 constellations. It has 24, like the others, on this medium Earth orbit, which is all the others are on medium Earth orbit, and then supplementing them with numerous ones that are geosynchronous orbit. In all the pictures you see of, in all the pictures you see of GPS, you see pictures like this of the satellites moving around. Each of these individual systems are focused on the person who's buying the satellites, or the country that's buying the satellites is often of more interest. And so to finish up, the vulnerability is that you need visibility of satellites. And so GPS just can't work where the satellite signals are not line of sight, and you need multiple. You also have this reliance on GPS. All modern navigation systems, almost all the major ones, are relying on GPS. And so what happens when you have a very low power, minus 130 DPM, sys power, it's easy to jam, it's easy to block, and there's even worse things such as beaconing, where you're relaying real signals but setting them up as decoys. And so those two are vulnerabilities. Many things forward for the future, and including, the nirvana of the driverless cars with GPS, but GPS cannot get you there by itself. So I will finish, since it is 6:44, and I welcome anybody's questions that you can send me, and I believe my information has been shared with the attendees.
Okay, if you have any question, feel free to share in the chat box. We will send it to them, ma'am. So thank you, ma'am, for truly enlightening presentation. On the behalf of everyone here, I like to extend my sincere to thank you for sharing your expertise us today. And we are honored to have had the opportunity to learn from you. Thank you, ma'am.
Thank you so much.
Okay, and now in this session, we invite to Dr. Muhammad Sohail Rahman sir, distinguished speaker, ACM, also distinguished speaker, IEEE Computer Society, and first year IEEE Computer Society Bangladesh chapter, fellow Bangladesh Academy of Science. His interesting topic like sequence may be mightier than with him. Sir, the floor is yours now.
Thank you very much, Tabil, for your nice introduction. Can you hear me?
Yes, sir.
Yes, sir,
Okay.
we can.
Thank you. So now we are going to dig deep into a completely different subject. We have been listening to fantastic talks by our colleagues on engineering, GPS system, and so on. I will try now to take you to the computational biology side. And here, as you can see, the title is Sequence Maybe Mightier Than We Think. What does mightier mean? It will be clear as we proceed. Just to give you an insight, here mightier would mean more informative. So what we are trying to do here, we are trying to have a marriage between machine learning as well as machine learning and life sciences. But this is not anything new because people have been doing machine learning in life sciences area for a long time. So what we are doing here, we are focusing on sequences only. And this is why we are trying to hypothesize the idea the sequence might be mightier than we think. So I am going to discuss some protein attribute prediction problems in this particular talk and why we are going to focus on sequences, that is primary sequences only. This will be clear shortly. So just to give you some motivation, there is ever increasing gap between sequence known proteins and attribute known proteins, and this is why we have been trying a lot. The biologists have been trying a lot to bridge that gap. And to reach the gap, what they have to do is they have to do wet lab experiments. And this is very costly as well as very time consuming. And this is why with the computer scientists come into play, because we can have computational methods, machine learning based methods, predictors, through which we can, with certain confidence, certain accuracy, give an idea about the attribute or the function of the proteins without spending much cost and time that is needed in the wet lab experiments. So there are a lot of questions: folding rate, structural class, cleavage size, DNA binding, subcellular location site, and so on. And there are a lot of answers as well. So there are a lot of predictors that have been used in the literature, successfully used by the biologists to at least filter some sort of protein functions before going to the wet lab experiments. So then why are we again trying to do this? Okay. Of course, there's the first motivation to improve the performance, but there is two other different motivations. One of the motivation comes from something called position-specific scoring matrices. Now, most of the predictors use SPSSM as their features, but it takes too much time to construct PSSM, and it depends on the database being used. So we wanted to avoid PSSM. And there's another point which is very important for us, that was that as features, many of the predictors actually use other functional attributes of the protein. Now, most of the time, when someone uses the functional attributes in a predictor, those attributes come from another predictor. So you see the problem. All the predictors that we have in the literature, including the one we will be discussing, will have some sort of errors, right? Maybe it's 90% accurate, maybe it's 95% accurate, and so on. So by using the functional attributes in my predictor, which I am importing from another predictor, I'm basically inviting some errors in my system, right? So we thought, why don't we focus only on primary sequences? And our hypothesis is that whatever function the protein is performing at some point in time, it must be somehow encoded in the primary sequence. So that is our hypothesis. So now this is the 5-step of developing a predictor, and we are going to only focus on this part. So I'm going to just restrict my talk within this part. So this is protein sample representation, and we will focus only on protein primary sequences. So now just going into a little bit of a detail, I'm not going to go into very much detail. The first thing that comes into the mind when we talk about the feature extraction from the primary sequence only, that is the amino acid composition. But here I give an example. This is for a particular prediction problem where we try to identify the Golgi body protein. As you can see, that there are two types of Golgi protein, trans-Golgi and cis-Golgi, but amino acid composition itself cannot differentiate between the two. So only taking this sort of very popular and very useful, otherwise useful features doesn't work for the predictor very well. So we started to dig deep from computational point of view. We started to look for various types of N-grams, various type of N-gapped dipeptides. What is an N-gapped dipeptide? This is something new probably for you. So this is like looking for a dipeptide that is a tumor with a gap in between. But then again, when we are talking about these sort of features, we need to dig very, very deep, and to get all the features from a particular sequence is very, very time consuming as well. So I'm giving you just a very short example to give you an idea of what we have been doing by extracting these features. For example, this is the amino acid composition. So we are trying to find out what is the frequency of a particular amino acid. So this is very easy to understand. Then if we are talking about dipeptides, we are looking into the sequence and trying to identify whether a particular tumor, that is a sequence, a subsequence of 2 nucleotides or 2 amino acids in this particular case, are present how many times, the frequency thereof. So here, for example, AA, we can find AA twice, we can find AP twice, and so on. So the same for the tripeptides, then 1 gapped dipeptides. So we are looking for AP, this dipeptide, but with a gap in between, with 1 amino acid gap in between. So this is how we extracted all these features. We can do this very easily with simple programming, but we need to dig deep into the sequences, and this sometimes takes too much time, and the feature space becomes very high. I'm going to come back to that. So there is another type of features which are called position-specific engrams. Here we basically ask for a particular engram, the presence thereof at a specified position. So this is a vector of Boolean vector, like yes or no answer. So we do this for a particular positions, up to a particular position, because otherwise it becomes a large, very large feature space. So I'm going to skip this because we have a little bit of time shortage. Now, the problem that we stumbled upon, this works quite well. We extracted the features, we created the machine learning pipeline, and we have got very good performing predictors in some of the cases. But in some of the problems, in some of the protein attribution problems, the feature space becomes very high. And we, the people from this part of the world, we work in a resource constrained setting. So what happened was, when we tried to do a feature selection exercise with the help of random forest algorithm, you probably all know about the random forest algorithm, with this number of features, slightly less than 30,000, the algorithm doesn't stop. So it continues, and it fails to provide you the feature selection, the feature importances, and so on. So we then came up with an idea that we will do the feature selection, we will do the feature ranking in individual feature spaces. Remember that I talked about 3 different feature types. One was position-specific features, one was N-gap dipeptides, and another was engram features. So what we did is, this is only for the resource constraint setting. We used random forest for ranking in the individual feature spaces and selected the top features, and then combined the feature space, and then again do the random forest ranking in that combined feature space. Then we again used SVM as the main classifier, and while doing the SVM, while working with the SVM, we also did some sort of feature ranking, which I will be explaining a little bit later. So at the end, we got some selected features on. So I will show you something very interesting here. Here we can see that this is the cumulative importance, that is the feature score, the ranking score. As you can see, when we take all the features, the cumulative importance is lower than when we take top 7,000 features, or for example, when we take top 5,000 features. So this makes sense to do the ranking and take the top features and then do the predictors, then build the predictors. But remember that the feature ranking that we have applied, we haven't done this from a biological point of view, right? We have done this from a computational point of view. So the predictor, the classification algorithm thinks that these features are the top performing features in the context of a classification algorithm. Okay, so I'm going to skip this for now because we don't have much time, but there is one very interesting feature here. Remember that we started with a feature space of 30,000, right? Slightly less than 30,000. Then we came back to a feature space of around 10,000. But at the end of the day, we did an exercise to identify the best model within this feature space. And it turns out that only with 289 features, we have a model which performs the best. So this is very interesting. So we have a huge feature space, but probably for a particular problem, the right model requires the right set of features. That is very important, okay? So again, what was the main motivation for us? The motivation is we want to focus on sequences only, right? And this is why I told you that sequence might be MITRE, sequence by MITRE than anything. So, and I will come back to this again, but remember, just to point out that we have a number of predictors like this, which we built only on sequences and have got very, very high accuracy. For example, our latest work was on CRISPR-Cas9 sgRNA prediction, which also did very well when we focus only on sequences. So now just to summarize, we focus on only the primary sequences. So this makes the predictor lightweight and less time consuming. Of course, sometimes if the feature space is very high, it will take some time, but it's nothing compared to the wet lab experiments, as you understand, and it is not costly at all. We do not use features from structure and functional domains. I have already discussed about this, and we do not focus on PSSM-based features. And for the resource constraint setting, that we are always in a resource constraint setting, so we provided a simpler and a generalized framework that we can use to build a particular predictor, where we worked on the individual feature spaces and then combine and then work on the combined feature spaces and so on. So what are we trying to say? What is our final message here? So we have various protein functions, protein attributes, and we want to identify a protein, a sequence known protein. What are the attributes of this particular protein? What we are trying to say is, let us focus on sequences only. You do not need to focus on functions, other attributes, position-specific features, and so on. Just focus on sequence only. Identify the right set of features from the sequence space, and then you will be able to get the best predictor at your hand. So we empirically promise the potential of focusing on primary sequence alone. However, biologically, what does this mean? We still do not have biological evidence to back up our hypothesis, our conjecture. So this is one thing that we need to do. We need to collaborate with the biologists and I try to convince our biologist friends to work on this, and we will be working on this soon, hopefully. But the empirical promise is overwhelming, because we have been able to beat all the predictors that uses functional attributes and other attributes with only sequence-based features. So we want to build on this promise. And of course, we provided a framework for other prediction tasks, particularly in resource constraint settings. So anyone who is interested to work on a particular predictor, if the data set is available, you can use our framework and you can work on predicting these things. So this is my last slide, just to acknowledge my collaborators as well as the students who work on these sort of research works. A number of predictors we published, and particularly the 3 predictors I have discussed here was a PhD study of Dr. Saifur Rahman, and other works were collaboration between other students and collaborators. Thank you very much. If you have any question, I would be happy to answer. And of course, we can communicate later as well through email and other means. Thank you very much.
I would like to take a moment to express my sincere appreciation to our distinguished speaker, Sohail sir, for his insightful and informative presentation. I think his expertise and knowledge on this topic has been extremely valuable to us. Thank you, sir. Dear participant, you can ask your questions through also Zoom chat box, then we will forward to it our honorable speaker. And also in this moment, I would like to introduce our another valuable speaker, Dr. Muhammad Shamsul Arifin sir, Senior Member of IEEE, Chair, IEEE Computer Society Bangladesh Chapter, Professor, Department of CSC, DIU, and Lian from Chue. And his speaks will be Green ICT for Sustainable Development.
Hello, Tabil, and hello.
Yes, sir, we will share you.
So I am actually noisy environment. Actually, can you play my video? Then I shall be ready for question and answer.
We will play. Sure, sir.
Assalamu alaikum and good evening to you all from Bangladesh. So my topic is on Green ICT for Sustainable Development. It is a part of International Congress on Recent Trends in Computing Technology 2023. So in this short talk, I shall try to give some information about or some ideas about green ICT, then necessity of green ICT and some other related issues. So what is green ICT? We all are talking about that means our earth, our society actually has many negative impacts on the computing technologies, as well as there are many other issues. So green ICT actually is a concept that deals with environmentally sustainable approach of information computing technologies. So in some detail, if we consider green ICT, we can say that it is the research and study of developing, designing, engineering, implementing, and using computing technologies in reducing the environmental impact of technology. So green ICT should deal with these issues. In green ICT, if we give a top level taxonomy or consider the top level taxonomy of green ICT, then we can divide it into two different parts. One is green ICT 1.0, that means make greener ICT. So it deals with solutions and technologies efforts to reduce the direct impact of IT or better ICT to the environment. And another is green IT or green ICT 2.0 is it deals with solutions that are enabled by ICT for improving the sustainability in the other processes. So one is direct impact ICT, another is other processes, those are using ICT, and we shall also consider the negative impact of the ICT in other domain. So this is the green ICT 2.0. If we give a further look in some more detail, then if we consider, that means green ICT 1.0, this is the big issue what deals with data center related sustainability, distributed ICT related sustainability, and other ICT direct sustainability. So these are the issues we are considering. Then if we consider data center related sustainability, it is a big issue nowadays because we have big data centers, big companies, and they are impacting our environment by actually consuming huge volume of energy. So that means clean energy to power data centers is necessary, server power management software, IT energy measurement, server virtualization, many issues in this case we can consider, solid state disk, and many other issues can be considered. So distributed ICT related sustainability, if we consider client virtualization, then thin clients, network efficiency, PC power management, these are issues. So here we are considering cloud computing services, IT asset disposal and recycling services, then managed that means printing services, many other issues we have to deal with. When we consider ICT 2.0, definitely we have to consider when we are adopting ICT related technologies in other domain, we must have to consider that that means it will also reduce the footprint of other processes and sectors. So this is also important for us when we are considering about green ICT. So most of us has a consideration or observation that green ICT actually deal with only data center related technologies, actually, or cloud computing related issues, power consumption related issues. That is the issue, reducing the that means power over carbon generation. So these are the issues. So there are many other fields as well, as for example, data center technologies, green cloud computing, green IoT, green databases. Actually, we are not considering these facts are less well known. So first three we are mentioning, we are well aware about this, but we have many other areas when we are considering green ICT. So green database, green data mining and information retrieval, green machine learning, green e-commerce and green e-government, green procurement, green agriculture, green education, smart grid, grid transportation system. So these actually belongs to green ICT. There are many other areas in the field maybe. So green data center related technology, if we consider then cooling related issues, computing related, and at the same time we can consider network related issues as well as architectural issues. All these issues can be considerations, and geographical or cloud related issues. So these can be considered when we are dealing with green data center. Then in green IoT, we have many issues as we are mentioning here. That means we are considering Internet of Things. Now it is highly deployed for smart cities, smart villages, and many other areas. So we need to consider the facts so that our IoT infrastructure is green. And for doing this, actually, we can consider different research-related factors, then integration between energy efficiency across the IoT architecture, then green applications to minimize their effects on the environment, reliability of green IoT with energy consumption models, context awareness with energy efficient IoT systems. So there are many actually opportunities to make our IoT green. So another efficient energy mechanism for IoT such as wind, solar, vibration, and many other issues. So we need to consider these issues because there are many sensors we are installing, and actually there are many issues to be considered to make this green. So in case of green cloud computing, we must have to, that means improve the efficiency in different ways, cost reduction, reducing carbon emissions, then reducing number of migrations, many issues, maintaining temperature threshold, many other issues should be considered when we are treating with green cloud. We also need to make actually software level green computing. We need to consider strategies, actually strategies when we are dealing with, that means software development. In our software development, we have to consider the concepts of green computing, use of green IDE and compiler, use of grid and cloud computing, recursion versus iteration. That means whether recursive process is never be a good because from the computing perspective. So we have to find alternative. If we have recursive and non-recursive solutions, we have to consider non-recursive one, less running time, use of energy, our data structure. So these type of factors should be considered when we are considering software level green computing. Then green data mining. It is another issue. Then projects and object execution. In these cases, we can consider that when we have different types of actually machine learning approaches, and performance specification, make, buy, sell. So transfer learning based approach can be a good consideration in this case. Then data. We have to consider, that means quantity, quality, representation, and data acquisition method and data storage. Actually, we have to ensure that there will be different issues, data aggregation and sampling, and then active learning, dimensionality reduction, many issues we can consider to make it green. Then computation framework, if we use that means reuse of intermediate results, approximate model algorithms. So these can make our data mining approaches green. Then IT infrastructure can also be considered so that is green. That is part of other parts we considered in our, that means cloud framework or in our data center technologies. So when we are considering data mining, we have to consider these issues. We know all are well aware about crisp data mining technologies. So we have to consider, that means crisp data mining with green design principles. We can consider this, identify and focus on the most energy consumption phases, share and reuse data models, frameworks and skills, use green energy, understand value, then collect. Actually, we should know what we have to collect. Then we have to start collect, then reduce data, dimensional reduction, main other execute, common operation only once, choose models that enable discarding of data on low energy storage, include only promising models and energy efficient algorithms. So this is actually crisp structure. Data mining people are well aware, but we have to consider these issues to make our data mining related tasks green. So when you are developing something, whether it is green or not, there are many well-known tools. You can use these tools when you are developing an algorithm or something, or how you are consuming energies. These are the free tools you can use, and you can go and you can use these tools to check the efficiency of your actually developed system. So in this research consideration, actually, green computing is not so new field, but for the developing countries, actually, we need to make a balance about greener technologies as well as many other issues. So research of green computing is not, till today, it is not up to the mark. Actually, there are also many opportunities. So in Bangladesh, and we are trying to do some research in this domain. Dr. Ahmed Wasif Reza, Professor, Department of CSE, East West University. He has a good group. Those are working with research. And from this research group, we are working in a collaboration from Daffodil International University, Chittagong University of Engineering and Technology, and East West University. And joint collaboration, we have some significant publications in this domain. These are some of those. So far, we have around 35 publications related to green computing. Most of them are actually theoretical framework as well as some implementation. So we hope we all will work together to make our planet green with the use of green ICT. So thank you very much to be in my short talk, and thank you.
I would like to take a moment to express my sincere appreciation to our distinguished speaker, Dr. Shamsul Arakan sir, for his insightful and informative presentation. His expertise and knowledge on the topic have been extremely valuable to us all. Thank you, sir. Dear participants,
Thank you very much.
you can ask your questions through Zoom chat box. We will forward it to our honorable speakers.
Thank you very much.
So in this moment, I would like to introduce our another valuable speaker, Dr. M. Moshool Haq sir, Dean, Faculty of ECE, Chuet, Chair, IEEE Bangladesh section. The floor is yours, sir. We can't hear you, sir.
Hello.
Yes, sir.
Okay, thank you so much, Sabil, for your nice introduction. And also, I'd like to express my sincere gratitude to the organizer who are organizing an excellent event under the banner of IEEE Computer Society Bangladesh chapter. So today, I'd like to talk about some issues about the NLP. And NLP is the most important technology for implementing the fourth industrial revolution, especially in the lower income countries like Bangladesh, India, and so on. So all about know that. So the fourth industrial revolution. So due to the time constraints, so I just skipped the basic concept of fourth industrial revolution. And in the 4IR, actually, we would like to develop a comprehensive model between man, machine, process, or any kind of system with an integrated system with the help of ICT. So that every minutes of activities of any kinds of machine or process can be monitored remotely, operate them virtually from anywhere of the world, and it can be possible to improve the efficiency of an industry which is be benefited in terms of mass productivity, supervision, complete automation, and so on. So the thing is that, there are lots of related technologies needed to implementing the overall process of fourth industrial revolution or 4IR, and to get the benefit of 4IR, for example, the AI, machine learning, big data, IoT, and robotics, and other technologies need to be combined in such a way so that can develop a smart industry or a smart environment or ecosystem for any organization. to get the benefit of fourth industrial revolution. So you can see that. So most of the technology is coming from the AI field. That means we're talking about the fourth industrial revolution, but the killer of the fourth industrial revolution or the key technology are almost on the AI field. And today, the development, the application of or adoption of AI technologies in industry all over the world is increased day by day. And also the Bangalore, which is the tech city of India, the recent study says that almost 80% companies are shifting their traditional system to the AI-based system so that they can cope up with the change of fourth industrial revolution. So that's why in the industry, 4IR is actually and not the other thing, is called the AI revolution. So based on the IBM report, so AI itself is considered as the heart of this new revolution, that is the fourth industrial revolution. And another term is called the AIUC. So in the AI revolution, the language, the automation, and the tasks of the system serve as the guide post for the AI provider. And also as well as the practitioner can follow the models, they can design, build, process, or deploy the technologies using the AI technique. So that's why in the next few decades, the world is changing with the interactive world. That means when the AI is deployed in all the industries or all the organization, and also the IoT is implemented in all the techniques or devices, then we get a favor of interactive world where we can talk or we can interact with each device or machine by use the language, because language is actually the easiest way for communicating or interacting to the rest of the world. So it may be the machine, it may be the process, it may be the any robotic agent, anything you can communicate with the language, because it's the effortless and easiest way which is developed by the human being from his childhood. So there is no patent is needed to learn the language by the human being. But most challenging thing is that, so when you're interacting with the machine as well as should be smart to understand the human language, interpret them as well, and also produce the appropriate response against the human queries or human interaction. So that's why to develop a smart world, to develop an fourth industrial revolution based industry, the machine should understand the human language as well, so that the communication between the man and machine should be natural, interactive, and effortless as well, so that we can materialize or get the benefit of full benefit of fourth industrial revolution. So that's why the NLP is one of the most important component to have the capacity of the machine as a human do with the other human. So recently, there are lots of systems, for example, the smart assistants or the chatbot is trying to develop by using the NLP technique so that it can interact with the human being. It's not only the interact, that also can understand the sentiment or emotion, intonation, and other sort of thing, and that can be very effective devices for the communicating to the human being and the rest of the world. So the recent studies estimated that the AI and NLP technology has the potential to contribute about $16 trillion to the global economy by 2030. That means we can understand that the NLP and AI is the powerful tools in the upcoming fourth industrial revolution, especially for the low-income countries. So from the human coming in the earth, the language is considered the most significant achievement or innovation of human being, so that there is a lots of people, lots of language, lots of color, and lots of geographical variation, but they can communicate each other by using the language. So that's why it's the very most effective and most effortless way to interact with the other humans. And also it could be possible to develop the machine that can be also the interact as a human being interact with other humans or the machine. So that's why, so NLP is basically is the automatic manipulation of natural language or human language. It can be speech from, text from, or maybe the combination of text and speech is called the multimodal. So NLP technology basically gives the AI system or the computer to have the ability to read, understand, interpret the human language, and it's maybe the most important or essential component for man and machine interaction. But the problem is that there are lots of resources available. When you try to develop the smart system in NLP-based smart system, there is a problem for the low resource languages. For example, around the world, among the 7,000 languages, only the 20 are the most focused, or is called the rich languages, based on the resource available or technology available in the world. And other the remaining languages is considered the low resources because it's the less studied. A recent study said that English and Chinese together make up or contribute to the 45.3% of the internet user. So the language, for example, the English, Chinese, Spanish, French, Japanese, and more other European languages or Western languages are considered high resource because the lots of corpus, digital content are available, which is the prime condition to develop the AI-based model, or specifically for the deep learning or machine learning model, because data is very important. If you have not the sufficient amount of data, so it cannot be developed a state-of-the-art deep learning or AI model. So that's why there are several languages in the world that are native to a sizable number of people, but the problem is that which may not have substantial amount of data set for training or develop an AI model. For example, in Africa and India, about 2.5 billion inhabitants are talking or interacting with their own language, but due to the less resource or less studies, less material, or less computer system, so they cannot be developed a smart NLP-based system. For example, recently the chatbot or the GPT 4 version is not fully capable for handle the low resource languages. So that's why the statistical or machine learning based model cannot be directly applied because of the data scarcity, especially for for example, the Bengali, Hindi, Tamil, or Telugu. So there are also other challenges when you deal with the low resource languages, especially for the Bengali. That means we need a extensive or the expertise is needed because only the computer scientists are not enough to implement the NLP system. There are lots of linguistic people are also involved to develop a complete or useful system in lower languages. But this is the big problem. The computer scientists and the linguistic to combine to form a team to develop a useful system. And also, when you try to develop a special tool, a specific tool, for example, a medical dialogue system, so you need the specialized knowledge or the relevant vocabulary. But due to the lack of information, lack of data set, it cannot be possible to develop a useful system. But sometimes you can use the synthetic data. So in that case, synthetic data might be helpful, but the problem is that the quality of the such non-trivial model is doubtful. And also the accessing the data. Maybe there is some data is available in the social media or the some other research person or laboratory, but getting the data and getting information from the others is always challenging. Also, when you develop a system, but the problem is how can you evaluate it? Because this is the, for example, if you develop a chatbot in terms of in Bengali language, so it's maybe the first one. So how can you evaluate and how can you understand that your system is benchmark? Because always you try to compare to the other model, and if your model is outperformed than the existing model, then you can say that yes, my model is maybe the better. Since it's the first one, so it may be the pioneer, but it always difficult to understand that your model is best or good. And also there are some other limitation for low resource languages because the resources available, and also it is difficult to fine tune the model basically for the downstream tasks. And this also might be the limit the range of possible tasks you can solve the low resource languages. But nowadays there may some lots of solutions are available. For example, there are lots of word representation or embedding technique. So you can apply this technique as well for your own data set, and that can understand the language pattern or language semantic that can the machine learning model can handle in better way. And also you can be develop the handcrafted, augmented or transfer learning technique to develop the data set, but is a lots of time consuming because for the deep learning based system you need a huge data set. So to develop a huge data set, annotate it perfectly, benchmark it needs a huge amount of time and resources. Sometimes the meta learning nowadays, the transformer-based model are popular, getting popular day by day. So sometimes it can be possible to use the meta learning technique, but the problem is you need to a high configuration resources or machine to deal with this large model. And especially the other difficulty is that so the text data is generating in social media in a expedited way, is exponential way. So that's why, and also the variation of human language and also the text, especially in the social media, the pattern, the writing pattern style is not the unique, it may be the diverse. So that's why the human language is exponentially complex and diverse. And to deal with this, the diverse data in a common form that can the machine can be understand very easy, because for using the machine learning and deep learning technique, the data should be structured. And due to the unavailability of benchmark data set or sufficient data sets, it's difficult to develop some technique in low resource language, especially there's no NLP tool, effective NLP tool for the pre-processing task. So that's why you need to develop the system from the scratch. So it needs lots of time, lots of effort, and lots of investment, but it's unavailable for the Bengali language context in recent days. But there are trying the several researchers in Bangladesh, which is visible in 1970, 1997, working in Bangla language processing to develop some kind of system. Basically, they're trying to develop the parsing, character recognition, syntax analysis, machine translation, rule-based. But most of the system is basically on the theoretical aspect and the rule-based. But when you try to develop the automatic system or a smart system, you need to use the machine learning or deep learning model. But without the sufficient amount of data, so it is always the challenging, and the pre-processing tool is always challenging to develop the state-of-the-art model for the lower resource language. So recently, there are other people are working with the machine learning and deep learning technique to develop the OCR, neural machine translation, text-to-speech conversation, summarization, and so other technique or text classification to develop the deep learning model. But the problem is that, so due to the lack amount of data, so their accuracy is always questionable. So there are lots of application in industry, application of NLP industry. Nowadays, the chatbot is very popular, and for the brand monitoring of a company, social media monitoring, or the smart search or automatic insight or sentiment analysis, there are lots of techniques are already explored, which use the NLP as an important component. So the corpus development is actually the most important part in terms of law language university. So that's why we are working with the developing some corpus, and most of them are already freely available in the publicly available, so any student can use it. So under the Chuet NLP lab, we have developed some kinds of resources, and few of them are already available with the source code and the data, so student can use that for their further resource or the further development. So due to the time constraint, so Sabil, how much time I get?
Sir, I think already is over, but you can finish it with
Okay.
short time. Okay, sir, no worries.
I'm just so
Okay, sir.
there are lots of technique I've already we are trying to develop in terms of binary language processing. For example, the emotion recognition. We try to develop the emotion recognition system by using the deep learning and transformer-based model. And already the primary result is published in the reputed journal. And also another important work is the aggressive text. So recently there are lots of text or abusive or the aggressive text or is called the undesired content are increasing in social media. So therefore, to detecting this aggressive text or the undesired text is utmost important for detecting the aggressive activities in the social media. So first of all, we would like to develop a data set. So based on the data sets, we develop a deep learning-based method, and we try to apply the transformer-based model and assemble it. And finally, we find that the assembly-based learning is maybe the better than the existing one. And also, we compare the work in the other system. And the most challenging is part the multimodal information. Nowadays, we can find that there's lots of MEMS information or MEMS content are available in the website. So it can be very offensive and it can be destroy some personal or the organization images. So that's why to early detection of these kinds of images or the information is helpful for the industry as well as the personal case. We also developed the system based on the transformer-based model or attention-based model, and we experimented with the developed dataset. And based on this, so there is actually the multilingual, that means that the Tamil, Telugu, Kannada, and English language as well. So 4 multilingual dataset are used or tested based on our developed model. And also there's another important thing is that nowadays the Bangladesh government is launching a project which is called the EBL ICT, Enhancement of Bangla Language through the ICT. So under this project, so they're trying to develop the 16 components, 16 tools based on the NLP. And already fewer is coming out, and the industry, for example, the generation of Approval Technologies, Gigatech, RAPE system, or IntelliSense, they're working on the NLP to try to develop the NLP tool that can be useful for the people of Bengali speaking. Okay, I come to the end. So there's a lots of work is needed compared to the high resource languages, and our NLP graduate or expert are high demand in locally and globally. So we need to establish a lot of NLP or BLP institute or research center in the national and university level. And also the most important thing that industry, academia, and government collaboration is needed to develop the real-world solution for respecting to the Bengali. And also the NLP Research Center or R&D cell startup should be give the high priority. And also the policy or guidelines need to be adopted by the government level to transform the academic research into the NLP product or service. So there are lots of barriers also, but NLP, especially the natural language, will be the key technique to interact with the world in the coming fourth industrial revolution, especially for the machine, to get the machine smarter as like as human being. So that's why human machine can collaborate or work in the same environment, which can be increase the effectiveness on the efficiency of any task. So that's why a collaborative approach with proper policy can overcome the existing barrier, and NLP product service can make a significant contribution toward the industry core and to achieve the vision of Smart Bangladesh. Thank you so much. So if you have any question or try to collaborate with the Tweet NLP Lab, so you can access our website and directly email to me. Thank you very much for your patient listening.
I want to take this opportunity to thank our outstanding speaker, Dr. Mashour sir, for his thoughtful and instructive talk. For all of us, his knowledge and skills on this subject have been incredibly beneficial. Gratitude, sir. Dear participants, you can ask your questions through chat box. We will forward it to our honorable speaker. Once again, thank you, sir. In this moment, I would like to introduce our another valuable speaker, Dr. Muhammad Atikur Rahman sir, University of East London, UK, Senior Member IEEE, Senior Member of TICA, website ahadvisionlab.com. The floor is yours, sir.
Thank you very much. Can you hear me? My voice
Yes,
is
sir.
clear?
Yes, sir. Yes.
Okay, thank you. Thank you very much. Indeed. So, welcome everyone. You must be tired by this time after having lots of information and wonderful talks from exciting speakers, especially from my friends and others. So I'm delighted to be part of it, and I thank the organizer for having me. So today I'll discuss about sensors. So it will cover IoT sensors and video, and I'll explore some of our works so that you can have a look. This is Osaka University, where I worked less than a year ago, and then University of Dhaka. Recently, I moved to University of East London, so welcome here. It's in the East London and next to the London City Airport. So my room is somewhere here. Oh no, not this one. Here. Okay. So I'm looking for definitely industry and academic collaboration. So here we have lots of people. So I just encourage them to engage me and contact me. And then we have some PhD scholarship opportunities. I shared the link so that you can have a look and fill the form if you are interested. So today's talk regarding IoT sensors and vision in the healthcare domain, I'll highlight some of the points. So basically we know RGB because you can see that red, green, and also this is red. There is no green here. But from RGB, we can also get skeleton body joint points. So body joint points. So you see, video is wonderful, image is excellent because we have lots of information we can get from it. But instead of this, because privacy is an issue. For example, because of video, I have to wear, good clothes, even though I am sick. Unfortunately, I cannot sit down, so I'm standing and talking like this way. But if there is no video, I could be just like lying on the bed or somewhere so that I can just talk. So it may happen that in many healthcare applications, video is not possible. On that case, skeleton body joint points can be very useful, or depth images, that would be another good point. So, but of course, limitations are there, as you can understand that. Video, you have lots of information, clarity, facial information, expression, what Professor Mushim mentioned about from text to understand emotion. But we know that from facial information, we have huge amount of work to understand emotion. But what about the privacy issues? So and from skeleton data, we get nothing. So there's the few things. And another point is that IoT sensors or smartphones, what we have, it's like this kind of low cost, not iPhone, okay? So smartphone even can have accelerometer, gyroscope, and other sensors from where we can explore different things. And not only that, many IoT sensors can be used for different healthcare applications. So applications are mostly on healthcare, surveillance, especially for video, man-machine interactions, and robotics, and so on. So video surveillance, sports, video analysis, understanding human activities by robot. In developing world, we don't feel the importance of robot or robotic systems to help people that much because we have lots of people and connected as well, and financial issue is another point. But there are many places where much less people, more elderly population, and not enough young people to support them. So what to do? So we need robot and robot-based systems, and these are extremely useful for many cases, and especially hospital, rehabilitation center, smart house, we can find many different applications. I'll explore some of those. and detecting fall down, not like this one, as you can see, and especially predicting before I fall down. Sometimes I can feel that, oh, my health is not good, I may have some problems, so better I sit down or take rest or something like this. So can we get those information from IoT sensors or video and so on? And daily exercise monitorings are widely used by different Fitbits, or Fitbit is the company, but I mean wearable or wristwatches. Patient monitoring outside the hospital. I'll cover 2 slides on that. Remote patient monitoring. Like, say for example, I have a problem, I'm not in the hospital, I'm at home. Can you monitor my physiological things or health conditions remotely from the hospital? Or even I can see this kind of things. And for falling, especially for dementia. By the way, if anyone is working on dementia, please contact, and I would like to discuss with you, because I'm going for some project on dementia issues. Elderly care system in case of emergency, another work, for example, remote monitoring of pregnant women. So I mentioned that remote patient monitoring, which is nothing but existing digital technologies to track health status, to improve health outcomes. Not easy, but you have plenty of money flowing, okay? So if you love money, then billions of dollars in the market, and probable market and so on. So you can see that it's coming and we have to go for it. So, but it's not easy. You need to do research and study and improve it. ADL is a term, you know, that activity of daily living, the continuous activity we are doing. From there, we want to get an overall impression about my health or my rehabilitation condition, or and so on. So this is another important thing. And for that purpose, sometimes we don't have much work, like egocentric, like for example, there is a camera or something, or there is a camera, and then I'm doing something, so you can, the way my eyes can see my hand, can we do something like this? And this can have lots of different applications. So we have large data sets, and we have skeleton-based data sets, and video-based, and we have sensor-based many data sets, especially physiological health-related signals, fall detection, medical applications, from wearable sensors or multi-sensors or so on. Now I'll share some of our work. So skeleton-based activity recognition, you can try, but the future target should be not only understanding or recognizing the current action, but can we predict the future based on the current situation? Or, for example, skeleton domain, there are lots of progresses, but still not up to the level of video domain, because video domain has been dominating for more than 2 decades in the development of human activity and behavior understanding. So, but luckily we have different motion capture systems before, but those are usually expensive. But sensors like Microsoft Azure Kinect, earlier it was Kinect version 1 and version 2, we can get lots of, not lots of, basically good joint points, about 15 to 20. Others are at the edges and lots of noises as well. So you can try and explore those things. So that, if you are a new researcher on a skeleton-based human activity recognition, what you need to do, that get the skeleton points and represent them in graphical manner, graph-based something, or another way, get the feature extraction, and finally go for recognition or understanding different activities. So when we do something, remember that physical movement, or say my wrist, this position, geo position at this moment, or considering from your camera, like your eyes are the camera. Now, so for example, I'm moving further, so definitely the distance is moving. I'm going up, down, so you see that the distance, X, Y, Z are moving. So based on the movement, so different points, the distance are varied, as well as angles are different. So if we can get different distance vectors, play with them in different ways, compute different angles, and see the relationship and so on, handcrafted features based as well as deep learning based structures can be useful to extract meaningful features from the different body joint points. So these are few things we can explore. And regarding remote patient monitoring, like patients in rehabilitation, for example, we have definitely fewer therapists and doctors all over the world. Especially in pandemic situations, we suffered a lot. Can we do something so that we can monitor someone remotely from home? Now you see that, say I have a stroke, unfortunately not yet, I don't want, and say I have some kind of a gait problem or walking pattern problem or some parties, in trouble, and I'm under rehabilitation. There are not enough doctors to evaluate my SIS score or BBS score to give me my position, and based on this, whether I need to stay in the hospital or not, this kind of things. But what about, we have some on-body sensors. Usually we don't like patients to wear on-body sensors, but sometimes we need, and any Kinect sensors, the Azure camera, for example, and then collect some of the things, extract something, and based on this, we try to improve our conditions and get some feedback. So just this is one example that what doctors try to do. They want to see that my both hands, I can do like this way. If I can do like this way 3 times, doctor will give me 5 out of 5. If I cannot do like this way and I have some problems, doctor will give me few points, maybe 1, 2, 3, something like this. Based on the total points, this is just one, they're based on 70, 80 points, we can see that what is the condition and so on. But you see that doctors sometimes touch the body. From a skeleton or even video, we cannot get this information. Sometimes some informations are very difficult to get. So we need multimodal strategy. But again, multimodality is not so easy because when we go for data collection, especially healthcare domains with hospitals and rehabilitation centers, not easy, but we need to check and explore in a pilot project and then go for a bigger scale. And similarly, like understanding the normal versus abnormal, problematic one. And on that case, not binary. Our life is not binary. How are you today? I can say, okay, I'm great, but sometimes maybe partially not great. At this moment, officially, I'm not great at all. So I should have action quality or movement quality or some problem. Okay, so what is this? Am I 30% good or 50% good, 80% good or something? So this kind of scoring is important in our life nowadays. Otherwise, we cannot get remote patient monitoring so easily. So RGB, video, privacy issue, but is it always? So one strategy you can explore that if you do not save the video for the future, then what you can do, you can just use use the RGB to get the process data and just remove the RGB data or video information. That would be one reasonable explanation. And when you have RGB, that's good. See, for example, if I do something, doctor can easily understand that I have pain, okay? Or you can easily understand my emotional things from my facial information. But it is not possible from skeletal data, let alone for sensors. Sensors are very difficult till now to get, instant emotions, unless it is very strong one. We are working on psychological indicators based on different sensor data, but still we find that, the relationship to find among sensors, physiological data, as well as different emotional things are still very difficult because we need the ground truth data, and to get the ground truth, it's not easy. I can say that I'm fine, or I can scale something, but maybe my physiological data is different because I have good tolerance, or I'm a strong man, or something like that. So even though I'm not, so skeleton based is another one, but we have less data, sensors. Sometimes we can use, sometimes we can't, and how many sensors we can use on the body, and what are the different kind of sensors we can use. So the problem is difficult because the progress is very slow. There are very slight differences often rehabilitation patients from one stage to another to get, but it's a huge scope to work, and also money as well as community build up and support. But the point is that how to engrave emotion, as I mentioned, privacy in it. So when I have pain, if you do not have video, you cannot see, all right? It hurts too much. And variations in psychology, why with robots or sensors, cameras versus human? Now, human-human interactions is very nice. We can understand, we can express, and so on. But when we interact with human machine, it's not so easy. So understanding pain or emotional things are very important. So, by the way, Tabil sir, when Thomas will come and my time will be up, so just let me know a few minutes before so that I can quickly finish. Because we have a very highly distinguished speaker after me, so I don't want that my talk will make delay for him. So this is very important. Thank you. So gait disorder detection is early detection of gait disorder may provide a safer life, especially for elderly people. Gait means walking pattern. So if you understand that sometimes I'm walking and my walking pattern suddenly looks different, it means that I have some problem. And if you can detect it automatically earlier, then it can be treated better and so on. So this is important that we always try with normal as well as abnormal cases. And this is one example. See, this guy is doing this kind of things, okay? And this is perfectly done. But when someone has a stroke and cannot do properly, so we can check the signals variations, okay, or differences, and based on this we can see that whether there is any development or progress or level and so on. We have been working with autism as well till now, and autism with therapy session. Like, can we have some system for children that when there are less amount of, so just think about this. I mean, this is a robot. Usually, a child should interact with a person. You can see her next to, but she is a therapist just for ground truth evaluation. Assume that I am an autistic child and I am at home. In front of me, only the screen or video or a small robot, and I am interacting with the robot or the video. Now, if there are sensors, Kinect sensors or other sensors or cameras can collect my data and then automatically evaluate me, that is a very good thing. Because sometimes we feel shy to communicate with others, like with the person, but we are happy with this thing. So these kind of things are extremely useful. We have been working on that, but much more to do because data set is very, very scarce, because only in this case we have only 61 kids and so on. We also worked on large care activity recognition and achieved some good results because real life nurses are extremely busy. Can we do something so that by understanding their activities, some of the activities we can go for automation, some of the cases we can see that who is working too much and then help someone, pull someone, something like this. So this kind of things can be possible. So at the Kyushu Institute of Technology, they developed several data sets and we participated and we got good results, but those results are still beyond the real-life applications because the accuracy is very poor. Even though we become first and second and earn money and prizes, last year we got nothing, unfortunately. But the point is that real-life data is difficult because huge class imbalance problem. Here comes the importance of statisticians or machine learning experts, that when you have a data set, so see that you can see that these are by different persons. So nurse 8, nurse 13, nurse 14. But different actions they are doing. Some of the actions are too much because we understand that nurses do some of the activities always much more, but others very few. So, and they are missing data as well. Some activities are for very short duration, some takes longer time. Human error there. How can we get a good quality annotated data set as well as to solve the problem and so on? So this is an open challenge. Even though our team has a good number of papers and good results, but still, it's beyond the demand, and so on. And another point is that we are collecting data from on-body sensors because in hospital environment, video and nurse, it's almost impossible to think. So we have on-body sensors or mobile phones and data. But what about, physical activities versus hard psychology? We know that during the COVID, many nurses and doctors were mentally exhausted. We salute them, but at the same time, we recall that how much tough time they had. So, it is important that we incorporate somehow psychology along with the physical activities so that we can get a genuinely better result and better information, because physical health is not the number one thing in life only. Physical and mental or psychological health, both are incorporated. So we have to consider this situation. So we have been working on running, okay? Unfortunately, I cannot run since a few days. I'm just in trouble. So, but after the trouble, see, I have a treadmill and I want to run there. what will happen if I start running on the treadmill? Maybe I'm running in a wrong posture, and if I continue like this way, maybe my health will be much more bad condition. So that's why it is important to work on a treadmill or somewhere that with sensors we can have a better thing, and we can just get good results and so on. It's still very difficult, but we can do. Elderly person monitoring system is important. We have been working for that, but it is also important that we do much more, so that if someone is living alone, his or her life becomes safer, as well as if any information we can collect by which the person is not feeling good and so on, it is very important. Some of you know that my mother died almost 11 months ago, while she was just preparing her iftar alone in her home on that time. So, and suddenly she died. So, but the point, it could happen that she had some symptoms earlier, but we don't know. She knew, but she didn't share with us. So what happened that suddenly, disappeared? So that this kind of things we can do. These are extremely important because millions of single people are living all over the world. Elderly people we need to do. So there are lots of opportunities to work. My work is almost zero in this domain because we have been working at Osaka University with the domain other team members, but till now, lots of progress from my side. So now regarding elderly people or patients, they don't like wearables. So you can say video, but video has a privacy issue. What to do? So maybe radar, Wi-Fi, or anything else. So you also need to explore and go for a focused area to see what can we do. Activity recognition using wearable. Wearable means not we have this kind of things, earbuds, yeah. It has speaker, microphone, but what about if we put some kind of IMU sensors, like accelerometer or gyroscope? Then if I move, then for example, say I'm listening some music or something, and I do like this way, or maybe someone religious, they will do something innovative way, and then moving, and based on the body movement or the sensors movement, if we can extract them just we did in our work, then we can get some extraordinary result, which is not possible in other manners. It's not easy because you need lots of data. What we did, that we tried with different human activities, but we didn't try with eating behavior or swallowing problem or socialization for speaking communication, especially for children with autism, or if I have a stroke and then I am trying to get back my oratory ability, speaking ability, and that is an issue as well. So we can explore those things. Again, wearables is just based on sensors. What about emotions? Can we incorporate some other sensors to collect stress level, because it is related to here? So someone can say, okay, go for EEG because we have patch-based EEG. We use this for, we have been using it at Osaka University since a year. Patch-based EEG device via Bluetooth, the data is transferring to study dementia. But again, the point is that elderly person put some patch and then remove it like this way. Oh my God, it's I will feel sometimes. So we have to check and so on. Again, I remind you, Mr. Kabil sir, that if the next speaker is ready, so I can start.
Yes, sir, he's already waiting, sir.
Okay, because I know that the time, my time is okay because I didn't take my 30 minutes. But so what I do, that we need to, I know that you guys are tired, so tired of my talks, so I just stop here. That activity or action based on different sensors have enormous scopes to work on different areas, especially for healthcare, not only for recognition or classification, which we do traditionally more. We need to go for the prediction to understand the future, evaluation to scoring different actions, especially for healthcare domain, and incorporate psychology and grade emotion, as well as diversity of human race. Otherwise, the data set will not be suitable. The work will not be suitable for different community and others. And of course, I'll share my link as well. That if you have any one interested for PhD, and I welcome you all to attend this 5th International Conference on activity and behavior computing called ABC. It will be in Germany and hybrid as well. And so I am grateful to my students and researchers and collaborators globally till now. Thank you so much.
Thank you, sir. I would like to take a moment to express my sincere appreciation to our distinguished speaker, Honorable Atiq sir, for his insightful and informative presentation on sensor-related work. His expertise and knowledge on the topic have been extremely valuable to us for higher study research. And dear participant, you can ask your question through Zoom chat box. We'll forward it our honorable speaker. And maybe one person has already has a question like, Ishwarya is doing in research in human activity recognition, and some concept she got idea, but still she have doubt. Can you give your email address? So, sir,
okay. So I'll give my email address and everything. So if anyone has any query, just please log me, but log me after 10 days because unfortunately I'm sick now. So I'm trying to address this. So just after 10 days, or maybe in April, I'll reply all of your queries. Thank you so much.
Thank you, sir.
So we are Tom Coffin is here. So welcome. Thank you.
Okay, thank you, sir. In this moment, I would like to introduce our most honorable speaker, Thomas Coffin, sir, IEEE Fellow, IEEE 2023 President-elect, past President, IEEE USA, past Director, IEEE Region 10. He was actually supposed to come fast, but at this time, his time was 5 a.m. o'clock. So thanks, sir, for sharing your precious morning time with us. And we are waiting for your valuable speech. And we are honored to hear from you about digital expression memory. Sir, the floor is yours now.
Thank you. Actually, it's not quite so bad. We have the time change here with daylight savings time. So it's now about 8 o'clock. So not so bad. But I will share here and give my presentation. And thank you for the last speaker. Can you see this?
Yes, sir. Perfect.
Okay, so I'm going to talk about digital storage and memory. So I am the president-elect for IEEE, but my day job is being a consultant working in industry on digital storage and memory. So I'm going to give a little talk about going through some of the different types of memory and storage and the way we're using things and how it's developing. So we'll talk a bit about different types of storage, how they sort of fit into memory, how they kind of fit into a hierarchy, depending on cost versus performance, capacity, cost versus performance. Then we'll talk about hard drives, magnetic tape. We'll talk about flash and SSDs, because we have to put tape in there a second, twice. A little bit about some of the other memories on the way there, then a summary, and then a little bit about the IEEE, if I could be so bold. So first, let's talk about, if you will, a digital storage hierarchy. So there's data storage is an important element of computing, and the growth of data is exploding. There's a commonly heard IDC study that was projecting something like 175 zettabytes of data generated annually by 2025. And that's up from about 60 zettabytes which were generated, say, in 2020. Now, most of that data would come from sensors, cameras, things like that, Internet of Things, smart cities, devices, have the most value when processed real time. In other words, you have to make a decision right now. But that's going to also increase the need to store and process data in the device or at the network edge, so it has an impact on memory requirements. And probably only a few percent of this data or the representative results of this kind of data will end up actually being stored for a longer term. Greater use of artificial intelligence techniques at various sorts of devices at the network edge and also in data centers, both training and also the inference for using that data later is increasing memory and storage requirements as well. In addition to the growth of data being processed, power consumption as well as latency, that is the time to get to data from when you want to access it, and also the data rates, the rate at which you can move data around, are important considerations in future system design. And that leads us to look at the storage and memory technologies that are going to enable us handling this data tsunami, creating value from it. So basic computers consist of a control unit that controls the operation of the microprocessor, a central processing unit, a CPU. It contains an arithmetic logic unit that does mathematical operations. These are traditional computers, especially von Neumann type architecture. They also have registers where data being processed is stored. A computer can also have cache memory for temporary storage of data as well as random access memory, or RAM. that serves as the main memory used by the computer. There's usually also a mass storage device where you keep data that is not immediately being processed. That would be, for instance, a hard disk drive or an SSD. And that stores the vast bulk of the data that's in a computer. And then the registers, caches, etc., are basically where you put the data immediately being processed. So cache memory makes data more often used by the CPU almost instantly available. That's achieved by building a small amount of memory. There's different types of cache. There's level 1 cache, which goes right into the CPU. And that cache is typically fairly small, about 2 to 64 kilobytes. There's level 2 cache that typically resides in a memory chip located near the CPU, but not in the CPU itself, but has a direct connection to the CPU. Dedicated integrated circuit on the motherboard, the L2 controller, regulates the use of level 2 cache by the CPU. This level 2 cache can range from about 256 kilobytes to 2 megabytes. High-performance CPUs have level 2 cache in the CPU chip versus a off-the-chip. And some computer systems have level 3 and even level 4 cache memory. The level goes up, the performance goes down, but generally the capacity of these caches increases, and that's because of various applications. There's static random access memory is primarily used in cache memory. Static random access memory basically will hold a data state until the power goes off, then it loses it. It has about 4 to 6 transistors for each memory cell, and therefore it takes up a fair amount of real estate on a chip. So SRAM, any significant capacity of SRAM, takes up a lot of real estate. It's larger than other types of memory, which may use, for instance, 1 transistor. And especially some of the emerging non-volatile memories are all single transistor devices. For a given storage capacity, that's more expensive. Registers and memory cells built right into the CPU, you said before, but there's things that are changing now. Von Neumann computers, you move data around a lot between things. And so energy and time are wasted doing this. They can be addressed by moving from a von Neumann architecture that's illustrated on the left to a memory-centric approach that's illustrated on the right. And that's led to protocols like CXL, Compactly Express, which allows memory disaggregation by moving some memory from behind the processor and creating a pool of memory. And that can be shared. It allows more efficient use of memory to address new problem classes. Also, there's possibility of heterogeneous computing by putting, for instance, accelerators in the same switch network, the CXL network. So you can do processing close to, or in some cases, even within the storage or memory device. So this includes low latency DRAM connected to the CPU, and this memory-centered computing is near memory, but far memory can be a lot of different types of memory. In this case, it shows SCM, which stands for storage class memory. This can be other types of non-volatile memory, for example. So CXL, backed by a big consortium, it's a switch memory channel and enable pooling of non-heterogeneous memory that has different memory characteristics, various latencies and data rates to the storage box. It supports, again, both memory and accelerators, do resource pooling, do aggregation with software, create virtual machines, containers, etc. DDR is typically used for working memory. Computers continue to be used for low latency memory to sometime in the future. Now, fast memory, this gives you kind of an idea of the performance of these various memory types. Fast memory, such as DRAM and SRAM and a DIMM, can provide data very quickly with nanosecond latencies as fast as 10 to the 7th megabits per second. The PCIe bus in computers is somewhat slower. That's what CXL, for instance, works on, as well as NVMe for storage devices. And that can operate at a little bit lower performance, say 10 to the 5th or 10 to the 6th megabits per second. SATA and SAS, which were common interfaces for hard disk drives, and some SSD devices have even more overhead, and thus have slower performance. Hard disk drive performance, normally SAS or SATA interfaces, has mechanical latencies, and so it has even slower performance, something like 10 to the 2nd or 10 to the 3rd megabits per second. So here's another view. Here's a view of the storage memory hierarchy in terms of a log scale of the bandwidth performance of the memory compared to the price per gigabyte of the memory. And you can see the L caches, L1, L2, L3 here, for example, DRAM, NAND, hard disk drives, and then magnetic tape. Magnetic tape is the least expensive, but it has the lowest performance. Hard disk drives next up, NAND, DRAM. There's a technology Intel had called 3D crosspoint, which is supposed to be between NAND and DRAM, for example. But recently it's come off, or at least ended development work by Intel on that. So let's talk a bit about some of these particular technologies. Hard disk drives are sophisticated electromechanical devices can access data from multiple surfaces using a rotary spindle motor that rotates magnetic-coated disks with a head that writes and reads information on the disk. That head is positioned with a rotary actuator motor, and you use the disk's rotation and head positioning to find data anywhere on the disk surface. The first one of these devices was actually created by IBM for their RAMAC computing system and available in 1956. So there's also electronics on the back of the hard disk drive, which runs the motors and also processes the data, sends data to and from the head. And so that's a hard disk drive, basically. Magnetic tape is another technology. It's actually been around, digital magnetic tape, since 1952, although analog tape was around well before that. There are many versions of magnetic tape, from open reels to modern cartridges, but the most popular type of technology today is called linear tape open, LTO, currently available in generation 9 with 18 terabytes of data storage, but going out to 14 generation projected. They happen roughly every 2.5 to 3 years, and they introduce the new generation, which has potentially over 500 terabytes of storage capacity. So let's talk about flash memory and SSDs. Flash is the extension of the floating gate method of manufacturing non-volatile memory. The first type of floating gate memory used was erasable programmable read-only memory, or EEPROM. That was invented in the 1960s, not developed in the 1970s. SSDs are developed off of that retaining electrons that are trapped, and that trapped electrons then can create a memory device. And nowadays available, of course, in many different form factors. It's very popular in client computers, things of that sort, and used in enterprise applications where higher performance is needed. Where we've gone from a planar flash, which basically built all the cells in a two-dimensional structure on a silicon chip, to now creating layers and layers. They're now up to about 230 plus layers, devices that are available out there with the projections they can go to perhaps 1,000 layers. The cost goes down somewhat with the increase in number of layers, but because of limitations on the process speeds, basically those cost reductions get less as we get to more. So there's other approaches that are taken, for instance, going to more bits per cell. All these things have trade-offs, but solid-state storage and SSDs become a very common technology. SSDs originally made to emulate the performance of a hard disk drive, which they're meant to replace. And like a hard disk drive, they have a host interface to communicate with the computer system they're attached to, and internal control electronics to organize and decode the data on the SSD and control buffer memory that helps with data processing and smoother writing and reading operations. The flash memory controller is an important chip inside of the SSD. It manages the NAND flash chips, writing and reading information from them as required by as needed. NVMe is a PCIe interface, the most dominant SSD protocol today. Again, it comes in various form factors. It also allows to work over Fabric, which allows creating pools of storage. So we talked about pools of memory before. Pools of storage, these are all part of big data centers, the idea of a disaggregation of traditional servers, pooling various resources, and then using software to create composable infrastructure devices as needed. And so in summary, data storage demand is exploding. It's leading to growth in digital storage requirements. That's driving all aspects of this whole hierarchy. And hard disk drives, magnetic tape, use magnetic recording. Hard disk drives as large as 26 terabytes available today, 30 plus terabytes using a technology called heat-assisted magnetic recording from Seagate are supposed to be available this year. LTO tapes are as high as 18 terabytes today, but looking towards larger capacities in the futures. Solid-state drives primarily use NAND flash memory and be an interface. Now dominant. It's used whenever you need higher performance storage, but it's more expensive than hard disk drives, and especially more expensive than tape. So flash memory is found in everything. It's found in data centers for higher performance layer, as well as in consumer electronic devices. So with that, just a quick thing about IEEE, because I know a lot of folks here are students and young professionals. IEEE is we're basically based on innovation. We're creating international standards, build technical communities, share and shape research. Our mission is to foster technology innovation excellence for the benefit of humanity. We have over 2,000 conferences in more than 96 countries annually, 5 million documents in Explore, published approximately 200 translation journals and magazines, 1,000 plus active standards and more under development. We have continuing education resources to help you remain relevant in your career. We have over 420,000 members in more than 190 countries. And we're also involved in global public policy and professional ethics. Things that have been the greatest value to me in IEEE have been, first of all, the access to information, continuing education, the stimulation of being a volunteer, leadership skills learned in doing that, and also the network of people I have as colleagues and friends throughout the world, of course, doing this. IEEE has expertise that is in many, many areas beyond just traditional electronics and power, getting into medical, cybersecurity, optics, robotics. My first society was the Magnetic Society, working on magnetic recording. Just an enormous number of different things we're involved in. And basically, it can be a resource for technology decisions. Technology is the basis of much of the world's economy today. We're the largest technical professional organization, are involved in all aspects of creation and use. IEEE publications are the #1 cited reference in patents. We foster efforts in future directions, technical roadmaps, which are being used by many people, tracking megatrends. We serve as public policy, resource for technical discussion. There was an event on Monday I was involved in where we were talking to a sustainability group of the UN about technology and standards and their role in helping to get a more sustainable world. So with that, I want to thank you very much for the opportunity to talk to you. And I guess I'm open for any questions if you have any.
Thank you, sir. Your insights and knowledge on the topic have been extremely valuable for us for higher studies, sir. We gained a lot of knowledge and insight from your talk, and I hope to have opportunity to hear from you again in future. So, dear participant, you can ask the question through Zoom chat box. We will forward it to our honorable speaker.
We got 2 smiley faces here.
Requesting to all open your camera. We want to take a picture to share our memory with Honorable IEEE President.
Thank you. I see a very good attendance, by the way. Congratulations.
Yeah, I mean, it has been always 100 plus from the beginning.
From 2 hours.
Hey Tabi, I cannot open my camera because you locked it.
Did you get your picture?
Yes, sir, it's taken. Thank you.
Okay, well, thank you very much. I appreciate the opportunity to talk to you folks and maybe to meet some of you in person somewhere.
Thank you, sir, for giving your valuable time.
Thank you so much.
Thank you, sir.
You're welcome.
If you have any question, you can ask after the campus. Also, we have Mustafa sir from our computer society. Sir, are you here? Okay, sir. For as our computer society representative, you can increase it a little better for us. Share something.
spoke in a very global perspective. So he gave a good overview to all our young students, and I think that's one of the issues students have, that when they go to classes and when they learn something in class, they have a hard time connecting it with the real world or with the global big picture. And I think all the speakers have done a very good job in making that connection. So I'm hoping in the future we'll keep on with this series of lectures. And I think one suggestion would be, if we can afford the time, we should allow for some live question and answer sessions after a few of the speakers. That's my comment. Thank you very much.
Okay, thank you so much, sir. So it gives me pleasure to express my heartful gratitude to S and everyone for making this Congress Day on a huge success. Your presence, active participation, and contribution have been instrumental in making this Congress a truly memorable and enriching experience. So I'd like to extend my special thanks to all keynote speakers who have contributed their valuable insight and experience to the Congress. So your presence has been truly inspiring, and we are grateful for the opportunity to learn from you, and the feedback from you will find in the chat box. So feel free to share your feedback from this form. So finally, I would like to thank all of you once again for attending the Congress and making it a truly honorable event. I hope that you have all found the experience to be as valuable and rewarding as I have. And I look forward to seeing you tomorrow again at 1 p.m. UTC and 7 p.m. Bangladesh time. So thank you all.
Thank you, Tabil. Thank you so much.
Thank you, guys.